I'm going to give a very short overview today of the DataNet Federation Consortium. This is an NSF-funded project with the goal of building collaborative research environments based on data grid technology. Within a collaboration environment, the goal is to be able to share data, share analyses, enable a community to develop a consensus on how they want to manage their shared data. We use these collaboration environments to build national infrastructure by federating existing community resources. I'll have a few more slides on that. The goal of this, in the long run, is reproducible data-driven research. Can we understand the provenance of the data? Can we understand the analyses that were applied to the data? And can we recreate the same data by running the same analyses at some point in the future? The way we build this national scale infrastructure is to provide interoperability mechanisms that enable community resources to interact with the collaboration environment, and then in turn to interact with the research environments where the analyses are conducted. A research analysis might be a local institutional cluster, a high-performance computing center, a grid community resource. We use the collaboration environment then to support not only access, but also manage the products that are created in the process of doing the research analyses. There are many different types of community resources that we have to deal with. There are information catalogs, as you just saw for Data 1. There are data repositories, federal agency collections. There are analysis services that are provided by multiple groups. Each of them tends to have a different access protocol, a different mechanism for supporting somebody's use of their particular resource. So within the collaboration environment, we need to not only be able to manage the community consensus on how you're going to share and organize data, but also provide the mechanisms that simplify access to this wide diversity of resources. So within the DataNet Federation Consortium, we're interacting with multiple types of resources. Over here, if I have on this side, we have a set of communities that are building their particular resources within this environment. So oceanographic or Ocean Observatories Initiative, engineering design projects, hydrology projects, multiple different disciplines are taking advantage of these community resources. In addition, there are resources that are provided by individual products or projects, such as Data 1, SEED, Data Conservancy, by federal agencies such as the National Climatic Data Center. There are a variety of analysis tools, mechanisms that you can apply within these environments that are accessible as web services. So routines that translate between formats, systems that manage workflows, systems where you actually apply the workflows to support a specific domain, such as hydrology workflow analyses. And then there are a wide variety of clients, different ways that people want to interact with this environment in order to either access data within one of the resources, support the community collaboration. So these range from social media tools to tools that manage reserved vocabularies, to tools that manage organization of information about each data collection. So within the collaboration environment then, we want to provide the mechanisms that allow each of these types of either domains, resources, or services to interact. From the perspective of a researcher then, what is actually going on? A researcher lives within a community. They live within a group of people who have similar interests, similar research goals. They would like to build a collaboration environment, as we saw in the prior talk, that enables them to collectively make progress on their research initiative. So there's some driving purpose, some goal that they have for the collaboration. They have a community consensus on how they want to manage the data, what formats they want to use, how they're going to describe the data, the types of analyses they want to apply. In order to make progress, they have to capture their domain knowledge. They have to come up with the mechanisms for understanding how to interact with that wide variety of community resources, how to manage their own research analyses so that they can rerun them at some point in the future, and then the policies they're going to apply within their own community for distribution, access control, retention, et cetera. And they'd like to share not only the data they're generating and the analysis procedures, but also the ability to re-execute these analysis workflows at some point in the future. So the long-term goal is reproducible data-driven research by capturing not just the metadata, but also the procedures that are required to create the data product. Within the DataNet Federation Consortium, we're addressing many of the challenges that were listed on the agenda for this meeting. So within the data grid that supports the collaborative research, we're able to register all relevant data, organize a collection of that data, share it, manage a distributed collection that may be distributed across both continental and intercontinental scales. We are able to distribute the data, move it back and forth. So for instance, if we're collaborating on a project that requires data from a federal agency repository, we can cache a local copy, do our analyses independently of the remote federal agency. We can automate the application of domain knowledge by capturing the analyses and workflows that can be shared and re-executed. And then we enforce policies in the distributed environment for controlling the collection that's assembled. So these policies are actually executed at each storage location where the data are located. We do have two major challenges. The environment I just described is traditional data grid technology that manages the properties of a collection. We are also very interested in managing the metadata itself, metadata virtualization. Each metadata entity within the DataNet Federation Consortium has properties. It has a creator, it has a time it was created, it has access controls, it's got a location where that metadata resides, it's resident in some schema. Metadata virtualization means I can then manage the attributes of the metadata independently of the database in which it's actually stored. And I can then do queries across that metadata across multiple types of schema. But we have a second challenge. In order to do reproducible data-driven research, we need to do knowledge virtualization. We have to manage the processes that were used to generate the derived data, including the provenance, where did the data come from, descriptive information about the data sets themselves, administrative information. In one sense, we're taking the metadata that we require and replacing that metadata with a function that allows us to generate the required metadata. So we have functions that generate the administrative metadata, functions that capture the provenance information, and then we're working on functions that allow us to do feature-based detection of data. So I represent data by the features that are present within it and describe those features based on a function that I can then manage within this environment. So the approach we're taking then is loosely organized along these lines. For a given collaboration, there's a driving purpose. Based on that purpose, there are a set of properties we want to associate with our environment. Required descriptive metadata, required formats, required analyses, distribution, retention, et cetera. In order to ensure those properties are enforced, we need policies which control what properties will be automatically generated and maintained within our environment. Each policy controls the execution of a procedure. That procedure applies the actual functions that generate the required property. So I might have a procedure which replicates data. I might have a procedure that extracts descriptive metadata from an XML file. I might have a procedure that implements retention. Each time we run a procedure, we generate persistent state information or administrative metadata that we can then manage. We can then write policies that verify the properties of our collection so we can prove to ourselves that we're self-consistently maintaining our own environment. And then we can federate these environments. I can build a data grid for one community, a data grid for a second community, federate them so they can then start sharing data. So we capture domain knowledge and policies, and we broaden the impact by evolving these policies to address the needs of each new broader community. A related project is an NSF Data Bridge project. Okay. This is trying to solve the challenge of how to address both the needs of individual researchers while enabling communities to build a consensus on how they're managing the data. So we take statistics for the information, how data is being manipulated within the data grid, look for relationships across that set of statistics, and then come up with a sociometric network analysis of communities that are applying the data. So for more information, there's a URL here for both the DataNet Federation Consortium and the iRODS data grid. And there are a wide variety of applications of this technology, not only at NSF, but across other federal agencies. Thank you.